Class example 2.21 asks us to divide a polynomial using both long division and synthetic division and to express our answers in the two different forms of division statements. Now, I'm only going to do half this question for you, but you'll have the answers you need then to try the other half on your own. Let's start by writing out the synthetic division. Here, we replace the original polynomial of 2x cubed minus 3x squared minus 5x plus 10 by its coefficients of 2, -3, -5, and 10. One detail we haven't mentioned yet is that if the polynomial were missing a term, which is to say that, for example, it had x cubed and then went right to having the -5x and was missing an x squared, we would need to write in a 0. Our synthetic division requires us to have a coefficient for each of the descending degrees. So now we need to write our divisors 0, which here would be +3, because x minus 3 is 0 when x is equal to +3. Remember that after dropping that initial 2, we will perform a multiplication and then an addition repeatedly. 3 times 2 makes 6. -3 plus 6 makes 3. 3 times 3 makes 9. -5 plus 9 makes 4. 3 times 4 makes 12. 10 plus 12 makes 22. The value furthest to the right will be our remainder. The next rightmost value will be our constant, and then we increase the degree by 1 as we move left each term. This means that our quotient is 2x squared plus 3x plus 4, and our remainder is 22. So our division statement would show that the polynomial is equivalent to the quotient plus the remainder over the divisor. Now, this is actually really easy to check graphically, because if we write the original division statement in our calculator, it will generate a graph. And if we then type our quotient plus remainder over divisor form, here we should get the same graph. Notice in that last example, I'm not missing brackets. I wasn't trying to rewrite the cubic. That is the quotient plus 22, the remainder, over the divisor. So those two things should be equivalent and show the same graph. If they're not, you've made an error somewhere.